Here it comes. All right, we are live from room 26. Gene, you have a question already? Suggestion. All right, well, let's introduce the problem first. We know that you're always going to be given one constraint. You have to find the other constraint. Sometimes you'll be given a constraint and you have to find more information about it. There's a couple problems like that, but you'll figure that out as we go by just remembering how to do it in this way. Okay, we know that x is greater than or equal to 4. So if you have any trouble with inequalities, I want you just to use number lines to visualize. Okay, so let's put a number line here with 0 and 4. So I know that it's saying x is greater than or equal to 4. Okay. Remember, just like an alligator, teeth open up towards the bigger. So we know x is greater than 4. Okay. We're going to first take this 4 and we're going to say, well, what happens? This is for my x domain, right? This is the domain. We're going to see, well, what happens to the y, the range, when I plug in x is equal to 4. That's the first step. So let's go ahead and plug that in right here. Y is equal to, what's this going to give us? 17. 12 times plus 5. Okay. So you see that 17 is what I get when I plug in 4. Okay. So I'm just going to put that on my y. 17. Now, the answer isn't that y always equals 17. Why is the answer not that? Why is it wrong that if I say y is always equal to 17? Why is that wrong? Why is that, Andre?
Because you're considering numbers not other than 4.
Right. Right. 4 was a main number. X could equal 4, but it could also equal what? Give me an example.
500.
5, 6, 560. Could be any number, right? E, not
No.
right.
E times 2.
No, you tried. No,
E times 2.
Yeah, barely. Yeah. We're all math snobs now. Okay. So what number should we pick? Let's look, and this is where I say look at the problem, and maybe there's a number that would be easier to plug in. Sometimes it doesn't matter, but you want to look and check. Would it matter? Would any number here make a difference? No. Sometimes you have a number on the other side where you're going to subtract it. Just look for clues where when you get to pick this number, the next number we're going to pick one that makes it easier to calculate. So I'm going to say let's just pick 10. So let's go ahead and do this again. We're going to go y is equal to 3 times 10 plus 5. What does that give us? 35. So I'm going to go here. I'm going to put 35 on. I know that it could be equal to 17. So which direction does this inequality go? It's 17 and greater. So the final answer is y is greater than or equal to 17. See how we find that? We find it by looking at, okay, we're given this domain restriction of 4. We plug in 4, we get our number, put on a number line for a range. You then pick another number in our domain that would work, so 10 would work. We plug it all in, we see 17. Now I know it's going in this direction, and I can conclude. You can see this, right? You can see that any number you add or you multiply here, it's just going to keep getting bigger. If I put in 100, we end up with 305. If I put in 1,000, we get 3,005. It's getting bigger and bigger. So it's that y is greater than or equal to 17. Okay. Who can do this problem? You guys feel good? Thumbs up, sideways, down for this? Okay, we're good, we're good. All right, I'm going to pause, and then we're going to come back for the continuing recording. All right.
Just watch this video.
So everybody's, I hope, pretty good with this rule. Remember that when we divide or multiply an inequality, by a negative, we have to switch that inequality. So we see here we divided by -2 instead of less than or equal, becomes greater than or equal. So Gene just had a really good input, something he had heard before, where to remember which one is which. I have a couple too, but we have less than or greater than. You might forget which one's which sometimes. And he was saying it makes sense. Less than looks like an L, similar to an L, kind of, right? Less than L. Okay, so this one is our less than. The other one was my riddle. What's less than 3? What's less than 3?
E.
Now you're right. Anything else?
Nothing.
I've told you this one before, right? You heard it? The answer is a heart. If you figured, or you remember that the less than symbol, less than 3, is this one. That's the only way to make a heart. if you made accidentally the greater than symbol, that's not a hard.
I think that's a hard. That's an E.
I don't know.
Angry
Oh,
cat.
it's like angry face?
Angry cat. Oh, I did it.
Mind blown. Alright, if any of those help you, go ahead and jot them down. Alright. The other thing to remember is that the greater symbol, right? It always likes to eat the number that is bigger. It opens towards the bigger number. It's a drag. Alright, so here we go with this. Now, we look and we have an if. So if x is less than or equal to negative 2, so that is our constraint. We're going to use our equation here, or sorry, inequality, and the constraint to figure out what's going on with my y values, right? Not domain, range. Okay, so let's make a number line for this to start. So this is just my domain number line right here. Here's 0, here's negative 2, and what is this saying? X is less than or equal to negative 2, so it's going in that direction towards the smaller numbers. Okay. But let's start by first looking at what does happen at 2. What happens at 2? So I want you to go ahead and plug negative 2 into our inequality and just see what happens to y at that point. Okay. So go ahead and do that on your own. I'll just start it up here. So you solve it out just like an equation. If it was an equation, you would get rid of this negative 2 over here, divide, and so on. So let's do that. Mind the rule. Mind the rule. All right, let's get that. Let's see what else we get. All right, so we're going to find information about our range. I say let's make a number line for that. All right, who worked it all the way out? Got a y value? Not yet? Ready?
Yeah, I got.
Here's where we have to do what? We got the negative switch going on because negative 2. So I'm going to have to switch that. Y is greater than, y is less than or equal to negative 2.5. Okay? So the thing is, I can go here to negative 2.5 for my range, my y values range, and I could say, well, it's saying y is less than that, right? Less than or equal to. So I know it's going that direction, but I want to be careful in just saying that's all. I don't want to just say it's just less than negative 2 because I've only looked at one value. I've looked at negative 2 for my x values. Remember, we're given x, we're finding information about the y. So what is a number? Looking at, actually, what's a number here that's less than negative 2 that we want to plug in? And that's yours to choose.
Negative E.
E.
Let's do a whole number just for convenience. Negative 4.
Negative E times 2.
Yeah. So we're going to plug in negative 4 and see what happens.
Hold on, I'm so confused.
I don't know what just happened there. All right, negative 4 minus 2y is greater than or equal to 3. Go ahead and solve that out. Put that on your number line, and maybe that's going to show you that, we could end up with, a line segment, and it's between those two parameters, but we don't know that yet. We just know it goes this way right now. So we're solving this out right here. I think that negative switch will happen again. Negative 2y is greater than or equal to 7. And then y is what? Y is good. You switched it. Perfect. Less than or equal to negative 3.5?
Yeah.
Okay. So here's the thing. We know it's less than negative 2.5. It's less than negative 3.5. So in this case, whenever you see that it's less than this and it's continuing to go, negative 0. Negative 3.5. includes negative 3.5, and it keeps going in that direction. You can see as we plug in numbers, there's no number we're going to put in here that really is gonna change this trend. But our goal, what we see here is if we have one going this direction and another one, then we know it's just from our first main parameter there. So I would say that our range, y is less than or equal to negative 2.5. That would be my range limitation. This is my domain limitation. That's it. How do we feel about that? Not bad? Okay. In some occasions, you're going to get a domain restriction, and you'll be given two different inequalities. Here's one equality. There's going to be another one. Just plug it in one at a time, and you're going to see from that, you're going to get the range limitation based on the two different equations. There's not a lot of places to go wrong with that, so I'm going to let you kind of explore that one. There's one problem that's tricky like that. Okay. So far, so good? Yeah? Typical spring break doldrums. We only have 30 days or so left. Isn't it quick? I thought you guys just arrived.
So many days.
I just learned all your names. I knew your names pretty well. I work hard on that. All right, if you have Desmos, get out Desmos. If you have your phone, let's get out Desmos. We're going to work on this problem, which has an option for us to go ahead and graph to find the problem. But we're going to get as much info as we can over here first. Okay? All right. Has anybody ever bought something in bulk? You bought something in bulk, right? Does anybody ever make T-shirts for like a club or anything? You done this? Okay. So if you were to order a T-shirt and you only order 10, is that going to be cheaper per T-shirt, or if you buy 100? Why is it cheaper for 100? If you buy 100 units, it's cheaper because there's a startup cost, there's a design cost, there's for silk screening T-shirts, you have to make a screen. You know, there's costs that are just part of it. So the more you buy, the cheaper it gets. That's the same thing for this example. Okay, so with this example, we're printing the phone cases again. We're printing the phone cases. And we have a $250 design fee. That's what we got to pay no matter what. The first 50 cases. So if I buy one case, or I buy 45 cases, or 50 cases, they're going to sell it for $5 each. After that, the next 100 cases, so from number 51 to 151, right? They are going to give us $3 each. Okay, so we're trying to figure out how many we can buy if we have a budget of $750. Okay. Based on our budget, we're going to find as many as we can buy. We're going to buy as many as we can. Which, you're right, isn't like a good business plan because you don't know how much you can sell it to and all that. But say if it's for like a club, it's for like the the sophomore class or something. It's getting these phone cases. So as far as up here, this first segment of phones here, we're going to call that X. So what is the least number of phones that I can order? And in fact, we could, if we were really, really not a good planner, we could order none. You just say, I want you to design this, and then you cancel the order.
It's amazing.
So how about this? Our X value is going to be between 0 and 50. Does that make sense? Just as like an idea, we're buying these, the first 50, so we could buy 0 or we can buy 50. Okay. How about this one here? We're calling the next group of cases we can buy, the next batch, the next 100 here. We're calling that Y. And what is the least number of cases or that I could purchase in that range?
Oh, just kidding.
It's not 50. It's 0. I want you to talk with your neighbor. A lot of this is critical thinking. Why is it that after 50 cases, the next 100 are $3 each, and why is it that I could buy 0 of those? If I bought 0, how many cases would I have? 50. Alright, so we don't need to talk. Do you see it's not from the beginning? because this range and this cost isn't saying that I've only ordered 0 altogether. It's saying within this range I've ordered 0 so far. What's the max I could order here?
100.
Good. All right. So far so good. What is my budget? So I'm going to put, this is my budget over here. I'm going to put all my costs over here. And what kind of inequality should I put between it?
Less than.
Why is it less than or equal? You're right.
Because you can't go over 750.
750 is your budget. Less than or equal to 750. All my costs have to be less than or equal to my budget. Do you don't have more money? All right. What's the cost that's in there no matter what? Bless you.
250.
250. Let's just build it that way. Now, if I call the first 50 cases, that batch of cases X, how can I represent the number of cases, the number of costs for those cases? What could I do? They're $5 each.
50 Oh, 5x.
5.
That's next step. We're going to get to that. You're right. Because you're going to be able to afford 50. We have to figure that out yet. Still. All right. So what do you think for my Y values of the next 100? Where should I put real Y? You see? Cost of the first 50, the next 100, the design cost has to be less or equal to 70. With your neighbor. I want you to figure out, since I'm buying as many as I can, what am I going to put here for my X value? Talk to your neighbor. What am I going to put in for the X value? Why do you know that?
Oh, wow.
Oh, they can't buy
What? Okay. Okay, leave it alone. No questions. How many of the original phones, how many of my X phones, which are the first 50, how many can I buy? Why can I buy 50? Right.
Well, you can buy any number, but for keeping that.
Right.
Well, you have to stop paying one.
And I'm definitely going to buy at least 50 because
It doesn't go over your budget.
that doesn't go over the budget, right? If I came back and I'm like, we can afford to buy 50, you'd say, well, you got more money than that. But since I need to first buy 50 cases before I even get to the second range of costs, I need to look here and see that our equation is going to change to this. So I want you to go ahead and solve this now for y. Let's go ahead and solve that for y. So this is just going to be 250. That's 250. So go ahead and solve for y with this setup. All right. If you have Desmos, I want you to start putting in this equation, or sorry, this inequality, that inequality, and actually, what we end up with, we can put that inequality in there. So just to practice, you got to find that less than or equal sign. Feeling like we're pretty good with this, so I'm going to go ahead and work it out. Plus 250, oh, that's just say 500. All right, so we get 3y is less than or equal to 250. Y is less than or equal to 83.3. But can we buy 1/3 of a phone case? They're like you get any leftovers. You get 0.05 of a case. These things are like little chips. They're not going to do that. Okay. So we just figured out actually algebraically all this. We know that, actually I want you then to put in this equation that's going to be the key one for Desmos. So we have this for Desmos, we have this, we have this. And from there we're going to figure out how many of our $5 cases and $3 cases are, and then we'll add it to get our total. All right. But let's go ahead and shift and look at Desmos for that. So let's look at Desmos. Let me just check I'm good. Whoa, and it's kind of sideways. All right, do you see I have the equations up there, or the inequalities? I keep saying the wrong thing there. The inequalities, here we have 0 is less than or equal to x, less than or equal to 50. So that's the red shaded area. You can see that x is between 0 and 50. We see if I take on and put the next one, 0 is less than or equal to y is less than or equal to 100. We have 0 is less, or y is greater than that and less than 100. So we have that in there too. Okay. This is actually the one that you put in. Okay, down here. 250 plus 3y plus 250 is less than or equal to 750. And it looks like we had to put in one more. So let's go ahead and do that. Let's put in this one. Let's put that full equation in there too. And you can subtract the 250 over if you like. That's fine. So 5x plus 3y is less than or equal to 500. It's going to be the same. So watch what happens. I click here, and remember that we established that the first 500 was our x value, that the next 100 after that was our y value. So let's look to see where all these things intersect. Right here, this is where all the shaded areas meet. And look what we have. What's the point? 50, 83.333. So you see, we could have with this just figured out all the inequalities, plugged it in, graphed it, and it is not this point up here. If you're wondering why it's not this point, it's because if it was the top point, this shaded area wouldn't be included. So this is the area where all the shaded ones interact. Okay? That tells me that I'm definitely getting 50 since x is representing the first 50. I know I got 50 of those. Y is representing the 100 after that. 83. How many total cases do we get? 130. All right. It's complicated, but what do you think? Can we do it?
Sure.
Yeah.
We can do it, right?
Yeah.
Okay. Let me just, for those at home. So all we did was we found it was the point 50, 83 using graphing. So I know that I got 50 of the first cost cases, and I get 83 of the cases at $3 each. We add those total together is 133. But the key was when you graph it, whatever you establish as your x value and your y values, those are the values, the number of cases that we represented for x, the number of cases we represented y. So that part is a little bit different. That's probably the newer thing that we haven't seen. Thumbs up, sideways, down. How do we feel? Okay, good. Okay. The classwork is in your workbook. It's the assignment on the left side there, so it's 1.2. So it's on page 23. And we'll end it there.